In this video, we're going to be looking at how to sketch the graph of the cosine function. I'm going to be assuming that you're already familiar with how to sketch the graph of the sine function. So if you haven't looked at that yet, you might want to do so before carrying on with this video. And if you want to find more tutorials on this topic, you can go to parkermaths.com/Y1 Trig. So before we start the actual sketch, I want to just make some links between the graph of y equals sine x and y equals cos x by using the unit circle. So on my unit circle, the green line is going to represent values of sine x, and the red line is going to represent values of cos x. And as we can see from where we started, sine 90 equals 1 and cos 0 also equals 1. Now let's look what happens if we shift both graphs by 30 degrees. We get sine 120 equals root 3 over 2, and we get cos 30 is root 3 over 2, so they still have the same value. Let's shift by another 30 degrees. This time sine 150 is a half, and cos of 60 is a half. And then one final shift. We get sine 180 is 0, and cos 90 equals 0. So if we keep moving these graphs in step, we keep finding that the values that we've chosen are the same for sine and cos. And now I want you to think about how we would get from the graph of y equals sine x to the graph of y equals cos x. Hopefully, from the unit circle, you can see that the cos graph is always 90 degrees behind the sine graph. And so we can think of the graph of cos x as a translation of the graph of y equals sine x by a vector minus 90, 0, essentially 90 degrees to the left. So on my screen now, I have a sketch of the graph of y equals sine x. And if I translate this graph 90 degrees to the left, I now get the graph of cosine x. And it's easy to check by considering the exact values we know for cosine x. Hopefully, you know that cos of 0 is 1. That checks out with the graph. Cos of 90 is 0. Cos 180 is negative 1. Cos 270 is 0. And then we get back to the beginning, and cos 360 equals 1. Just like with the sine graph, the graph repeats itself every 360 degrees. And so we could continue the graph indefinitely in either the positive direction or the negative direction.